Okay guys, this is another domain and range example, but this one's slightly different. So I wanna show you how to properly label your domain and range for a piecewise function that looks like this. Okay, I color coded it again, but they're two different functions. Okay, and I'm gonna grab a marker here and a ruler. Domain are my x values and range my y values again. So for domain, I'm gonna say, okay, domain. I want to go from least to greatest, and same for my range. I'm gonna start with my domain here, and ask myself, if I look at my x values here, and I just continue going to the left, am I gonna see one of those lines? Yes, I'm gonna see this red one because it goes up and to the left. And right now for x values, we're mainly looking if it goes on to the left forever. Yes, it goes to the left forever and ever and ever. It's got an arrow. It goes on forever and ever and ever. So no matter how far I go to the left, I will see this red line. So all the way to negative infinity, I will see a red line, comma. I'm going to continue here and start going to the right to positive infinity. Notice here at x equals 0, this dot is closed, so it actually lands on this red one, but not on the green one. But as soon as I start moving to the right, as soon as this one ends, this one picks up. So there's never a gap. I will always see a value here, okay? Always see a value, and no matter how far to the right, this is going to right forever. I will always see a line, and to the right, I'll see that green line. So positive infinity. For the range, that's where things kind of change. I'm gonna start from least to greatest. So I'm gonna start with my negatives and then move up for my range, for my y values. Now, at negative infinity, way down here, I don't see anything. I don't see anything. Even when I start getting here to y equals -10, y equals -9, and I don't see, notice I hit no line. My lines are going, this one's going that way, this one's going that way. I don't hit any of those lines, so I can't label, I have no range there. There's no range. I'm not hitting the lines until I get here. Now, I don't hit that open circle. I get really close, and this would be my y value. Here would be my y value, so here would be at y equals 0. This would be at y equals 1. And that is where this open circle is at. Okay? That's as soon as I see an open circle or a closed circle or a line, that's where I start recording. Oh, okay, this is where I first start seeing values for y. Okay, so I'm gonna put a parentheses, and what value is this? This is y equals +1. So I'm gonna write a 1, comma. If I continue going to greater numbers here, hey, I continue seeing graph here. I continue seeing graphs, and both of these graphs are going up forever. So no matter how far up I go, I will run into one of those lines. So I'm gonna write a positive infinity and close it. I'm gonna add this right here, just like close and dots and close dots and open dots, we have to do parentheses and brackets, or parentheses and square brackets, whatever you call them. Okay, square brackets is when I actually have a value or a closed dot there, and open is when I either have negative infinity, positive infinity, because there's no way I can actually land on negative infinity or positive infinity. So that's why we do the rounded or the parentheses. Or when I see an open dot. Okay. Notice here, when I first started seeing values at y equals 1, I ran into an open dot at 1. Meaning it gets really close to 1 but never lands on 1. So that's why the 1 got a parentheses, because there was an open dot. If this dot was a solid dot, if it was solid, I would still begin here at y equals 1, start seeing my graph. I wouldn't see any graph down here. But as soon as I get here, I start seeing graph. But that's a closed dot. So let's just say that if this was a closed dot, then I would use a square bracket. It would still be at y equals positive 1, but I would change this to a square bracket. This one would stay as a parentheses because there's no way I can land on positive infinity. And that's it.